All right, for this video, we're actually going to pause in the beginning this time because we're going to talk about the derivatives of inverse functions. But before you understand that, I want you to go through this first part right here all the way through f. And I want you to remember that when you talk about an inverse function, the inverse function, f inverse of x, which is this guy right here, that means you take a function and you flip all of its coordinates across the line y equals x, which means you flip all of your coordinates. So if like 3, 4 is on the original, 4, 3 is on the inverse. So I want you to take a second and pause this video until you finish f. I'll pick it back up, I'll explain what I got for those, and then we can move on. But it's not going to make sense and it's not going to really sink in unless you've done A through F on your own. So please, 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 please pause the video and then come back. So I'm really hoping that you did pause this, and if you did, you were asked to take the function f of x equals the square root of x and graph it. And I graphed that in red because you're going to see both at the same time here. And here's the square root of x, okay? Then it said find f of 4 and f of 9 and use those to evaluate points. So basically f of 4 was 2, f of 9 was 3. So the point 4, 2 and 9, 3 are on the graph of radical x. So then if 4, 2 and 3, 9 are on the graph of the function, its inverse would have 2, 4 and 3, 9, because when you take an inverse, you flip-flop the x and y coordinates. So if I use that and then flip it over the y equals x line, I get this green graph right here that looks like that. So now I want to evaluate f prime of 4 and f prime of 9. So f prime of 4 is the derivative of f, which is 1/2 x to the negative 1/2. Evaluated at 4 is going to give me 1/4. And then f prime of 9 is going to be 1/2 times 1/3, which is 1/6. I have that over here. And then it said use that graph up here, estimate the slope of f inverse at the point by sketching the tangent lines. So I sketched f inverse. I sketched in these black tangent lines, and I realized, wow, those are pretty steep. The slope at 2 is kind of close to 4, and the slope at 3 is almost too steep to estimate. But thinking about what f asked, what's the relationship? Well, I got 1/4 here and then 4 there. I got 1/6 here. What if I were to get 6 there if I really tried to estimate it? Well, in fact, that's exactly what happens. If f of a equals b, if on the original function you plug in a and get b, then the derivative of the inverse at b is 1 over the derivative of the original at a. So this is kind of a confusing thing to say, but what I always say is the derivative of the inverse function is the reciprocal of the derivative of the original at what I call the inverse point. So my slope at 2, 4 is the reciprocal of the slope at 4, 2 on the inverse. So you look at that, we'll call it the corresponding point, and take the reciprocal of the derivative. All right? So what is that going to look like here? So f of x is x minus 1 cubed minus 4. Find the slope of f inverse at the point where x equals 4. So if I want to find the slope where x equals 4 of f inverse, the first thing I want to do is say basically what this means is the derivative of f inverse at x equals 4 is 1 over the derivative of the original at y equals 4. Now, here's one reason I write it that way. This is x equals 4 on the inverse. So if x equals 4 on the inverse, then y equaled 4 on the original. So what I'm going to do first is say, all right, let's let y equal 4 on the original. X minus 1 cubed minus 4 equals 4. Well, that's only going to happen, let's see, when x minus 1 cubed is 8, which means x equals 3. Because 2 cubed is 8, so x is 3. So I have to take 1 over f prime of 3 to find the derivative of the inverse at 4. Let me say it again. If I want the derivative of the inverse at 4, I need to know when the original equaled 4 and find its derivative at that point. I figured out that the original equals 4 at 3. Now I'm going to go 1 over f prime of 3. So f prime, using the chain rule, is 3x minus 1 squared times 1. So f prime of 3 is going to be 3 times 2 squared, which is 12. Whoops. Is 3 times 2 squared, which is 12. So 1/12 is the derivative of the inverse at 4. Maybe I should have given you more space there. I apologize. All right. So let's do another one. This only makes sense the more you do. You kind of need to see this a lot before it really starts to sink in. So let's now take a peek at this one. If f is 1 to 1 and contains the point 27 and f prime of 2 is 4, find an equation of the line tangent to f inverse at 7. So if I want a tangent line to f inverse at 7, that means I'm taking the derivative of f inverse at 7, which is 1 over the derivative of the original when y equals 7. All right, so when y equals 7 on the original, oh, look at that, x equaled 2. So that's going to be 1 over f prime of 2, and 1 over f prime of 2 is 1/4. So there's my slope of the tangent line I need. So when x equals 7 on the tangent line, I have y minus y1 equals mx minus x1. Now I need the y value. So if x equals 7 on the inverse and y equals 7 here, that means if x equals 2 on the original, y equals 2 on the inverse. In other words, if 2, 7 is on the original, then the inverse has the point 7, 2. 7, 2, reciprocal of the slope of the original. Okay? Moving forward, if x is 1 to 1 and has a tangent line of this at x equals 3, find the derivative of the inverse at -1. Okay, so if I want the derivative of the inverse at -1, the derivative of the inverse at x equals -1 is 1 over the derivative of the original at y equals -1. Well, let's see. I don't have the original, but I have a tangent line to the original at 3. So one of the things you need to know is if you have a tangent line at 3, the y value of that tangent line is the same as the y value of the original. So if I plug in 3 to here, I'm going to get y equals -1. So I just figured out if x equals 3, y is -1. Well, I really wanted to know what is x when y is -1. It's 3. So I need 1 over f prime of 3. Well, f prime of 3, wouldn't that have a lot to do with the tangent line? It would have a lot to do with the tangent line. It would be the slope of the tangent line. So this is going to be 1 over -2, which is -1/2, and that's the derivative of the inverse. It's not going to make perfect sense. This is one of those things that every time I teach it, I try to find something that's going to make it easier to say out loud. There's really nothing that makes it easy other than the derivative of the inverse is the reciprocal of the derivative of the original at the corresponding point. Sometimes, I just got to say it, math is complicated. If you can understand it, great. If you can't, just follow the rule, okay? So let me keep going here. The graph of f contains 3, -6. F prime of 3 is 2. F prime of 6 is 4. Find the equation of the tangent line at the point where x is -6. Okay, so if x is -6 on the inverse, then x is 3 on the original, and f prime of 3 was 2. So if f prime of 3 is 2, then the slope of the tangent line is going to be 1/2. Instead of writing it all, let's think about it in your head. The derivative of the inverse at -6 is the derivative of the original at 3, which is 2. So there's the tangent line for my slope. And if f inverse contains the point -6 comma y, and the original contained the point 3 comma -6, then this must be -6, 3. So my tangent line is y minus y1 equals mx minus x1. I did a lot behind the scenes there. So find a way that it makes sense and use that. All right, so fill in the missing blanks here. I like this one. I made this up on my own. So let's see. Here's f. F contains the point 0, 1. 1 something, 2, 4, 3 something, 4, 7, 5, 8. Okay. This should say F inverse. I'm sorry, I don't know why that's dropped down. This should say F inverse. This negative 1 should look like an exponent. So, 0, negative 2. 1 something, Well, if F contained the point 0, 1, F inverse contains the point 1, 0. If F contains the point 2, 4, F inverse contains the point 4, 2. Right? And let's see, if F contains the point 1 something, well, maybe this 1 shows up in F inverse. Oh, look, there it is. F inverse contains the point 3, 1, so F contains the point 1, 3. And let's see, F contains the point 3 something, F inverse contains the point 5, 3, so F is 3, 5. See how I did that? I just swapped coordinates. 0, 1, 1, 0. 1, 3, 3, where is it? 3, 1. 2, 4, 4, 2. 3, 5, 5, 3. 4, 7. If that went that high, we don't have to worry about it. All right, so now let's talk derivatives here, and how are these going to work? Well, let's try to fill in the F inverse row first, and then we'll see if we can fill in this F prime row. So the derivative of F inverse at 3, for this box right here, I want the derivative of F inverse at x equals 3, which means I should find the reciprocal of F's derivative, pardon me, at when y equaled 3. So here's F, y equals 3 right here. So y equals 3 right here. The derivative of F when y equals 3 is 1, which means the derivative of F inverse when x equals 3 is the reciprocal of 1, which is also 1. All right, now let's try 4. So the derivative of F inverse at x equals 4 is 1 over the derivative of the original when y equaled 4. So in the original, y equals 4 here. So the derivative of F when y equaled 4 was 2. So the derivative of F inverse is 1/2. Okay, one last one. So this is when x equals 5, which means I'm going to look for when y equals 5 on the original. So when does y equal 5 in the original? Right here. The slope of F prime, F prime, when y equals 5 was 3, which means the slope of the inverse is 1/3. Okay, now what about this guy right here? Well, let's see. This would have to have something to do with this inverse row, because I have that thing all filled in. So let's think about this for a second. This 1 over f prime of x when y equals 1 would be the derivative of f inverse when x equals 1. So when x equals 1, F inverse had a slope of 1/2, which means that 1/2 is 1 over F prime when y equals 1. Well, y equals 1 here. 1/2 is the reciprocal, which means 2 is the slope of F. All right, long story short, I know this is confusing, and I'm sorry about that. I can do my best to try to clarify it, but you just need to know that the derivative of the inverse and the derivative of the original are reciprocals at their corresponding points. Okay, so we need a joke for this one. What should you put up if it's raining in the safari? What should you put up if it's raining when you go on a safari? An umbrelephant. I know it's not going to rain on safari a lot because it's a desert and it's dry, but still, it's an umbrelephant. Come on, it's funny. Enjoy your day. Try not to be confused for the rest of the day like you've been confused for the last 15 minutes. Yay, calculus, but boo, no logarithms today. That made me sad. Bye.